When it comes to artificial intelligence, some challenges are just way tougher than others. And for a long, long time, one of the biggest final frontiers has been high-level mathematical reasoning. It's one thing to calculate something, but it's a whole other ballgame to actually reason like a mathematician. Today, we're going to dig into a major breakthrough that pretty much rewrites the rules for how AI can learn to solve really hard problems. So what makes this so difficult anyway? Well, competition math isn't just about crunching numbers. It demands creativity, intuition, and these long, complex chains of structured logic. Large language models are fantastic at recognizing patterns in language, but this kind of rigorous, step-by-step logical thinking, that's been a massive hurdle. It's really the ultimate test of an AI's ability to genuinely think, not just predict the next word. And for the last few years, the only AI models that could even take a swing at these problems were the absolute giants of the industry. You're talking about things like GPT-4 or Gemini-Ultra. And while they're incredible, they're also closed source. That means their inner workings, their training data, it's all a secret. This basically left the entire open source community, all the public researchers and developers, playing catch-up in the race to build these powerful reasoning machines. But then this happened. A brand new model called DeepSeekMath with a relatively small 7 billion parameters didn't just compete, it completely shattered expectations. It scored an incredible 51.7% on the notoriously difficult math benchmark. That is a huge leap, and it absolutely smoked models more than 4 times its size. So the big question is, how on earth did they do it? Well, the answer lies in this really brilliant 3-part strategy. It's kind of like a secret sauce for teaching an AI advanced reasoning. We're going to unpack that whole recipe piece by piece to understand how this little David-sized model was able to take on the Goliaths of the AI world.
Okay, so the recipe has 3 key ingredients. First, a much better data diet. You gotta feed the model the right kind of information. Second, a smarter foundation, so building on a really powerful base instead of just starting from zero. And third, a more efficient coach, a totally new way to fine-tune the model's skills. Let's kick things off with the most fundamental part of all, the data. The DeepSeek team basically saw the public internet as this untapped gold mine. They meticulously filtered a massive web dataset to pull out a staggering 120 billion math-related tokens. Those are just pieces of text. To put that in perspective, that's almost 9 times larger than the leading public math dataset out there. It just goes to show you, high-quality data is out there if you know how to look for it. Now, here's a really surprising discovery they made. For a while, the common wisdom was that you should train these models on scientific papers from places like Archive. But the researchers found that this data brought, and I'm quoting here, no notable improvements. The real magic, it turned out, was in the diverse, multilingual math content they carefully pulled from the open web. All right, that brings us to ingredient number 2, a smarter foundation. Instead of using a generic language model, they started with DeepSeek Coder, a model that was already fluent in programming languages. This was just a genius move. See, code, just like math, is built on pure logic and structure. So this gave the model a massive head start, basically preloading it with the core skills it would need for logical reasoning. So, they had the right data and a really smart foundation. The final step was to hire a better coach to perfect its technique. This is where a new algorithm called Group Relative Policy Optimization, or GRPO, comes into the picture. You can just think of it as a super efficient training method that sharpens the model's reasoning skills, rewarding it for correct chains of thought and steering it away from making mistakes. And here's what makes this GRPO coach so efficient. Standard reinforcement learning methods, like one called PPO, they're just resource hogs. They need 2 big AI models running at the same time, one to do the action and a second critic model to judge that action. GRPO cleverly gets rid of the need for that critic. By just comparing a whole group of potential answers against each other, the model can essentially coach itself, which dramatically cuts down the memory and the computing power needed. Okay, but does this 3-part recipe actually work? I mean, a great theory is one thing, but performance is everything. So let's look at the results and see how this new model actually stacked up against the competition. First up, let's look at the base model. And get this is before that super efficient GRPO coaching was even applied. Just with the smart data diet and the code-based foundation, the 7 billion parameter DeepSeekMath base model scored an incredible 36.2%. That's already way better than Lemma 34b, which is a specialized math model almost 5 times its size.
This just proves how powerful that initial setup really was. But then, after they applied the GRPO coaching, the final score just rocketed to 51.7%. The 7 billion parameter DeepSeekMath didn't just beat giant open source models like the 72 billion parameter Qin, it also flew past closed source powerhouses like Gemini Pro. This was actually the very first time an open source model ever crossed that 50% threshold on this benchmark. It's a huge deal. So yeah, this is a landmark achievement, and its importance goes way, way beyond just solving math problems. What this breakthrough really does is provide a new blueprint for creating highly capable, specialized AI models without needing the budget of a tech giant to do it. So what are the big takeaways from all this? First, public web data is an undervalued treasure trove if you know how to use it. Second, starting with a code-trained model is a massive shortcut for teaching an AI how to reason. Third, smart design can let smaller, focused models run circles around generalist giants. And finally, new efficient algorithms like GRPO are democratizing cutting-edge AI, putting way more power into the hands of the open source community. You know, this whole thing wasn't just about creating a math whiz. It was about proving a methodology. It showed that with clever data curation, a smart foundation, and efficient training, the open source world can tackle AI's grandest challenges. And that leaves us with one final, really exciting question. Now that competition math has been cracked, what supposedly impossible frontier is going to be next?